Today I'm talking about the factors. Factor addition. Factors can be added together to form a resultant factor. This is typically done by adding the corresponding components of each factor. For example, if you have two factors in a two-dimensional space, factor 1 with component x1 and y1, and factors 2 with component x2 and y2, their sum would be a new factor with components x1 plus x2 and y1 plus y2. Factor subtraction. Similarly, factor subtraction involves subtracting the corresponding component of the factors. Using the factors from the previous example, the difference between factor 1 and factor 2 will be a new factor with component x1 minus x2 and y1 minus y2. Scalar multiplication. When you multiply a factor by a scalar which is a single number, you multiply each component of the factor by that scalar. If r is a scalar and you want to multiply it by factor 1, the result would be a new factor with component r multiply x1 and r multiply y1. The associative law states that the way in which numbers are grouped in an operation does not change the result of that operation. This law applies to both addition and multiplication. Associative law for addition. For any three numbers u, v, and w, the equation u plus v plus w equals u plus v plus w. Commutative law. The commutative law states that the order in which two numbers are added or multiplied does not affect the result. Commutative law for addition. For any two numbers a and b, the equation u plus v equals v plus u. Additive inverse. The additive inverse of a number is another number that, when added to the original number, yields 0. The additive identity, for example, the additive inverse of the number is v is negative v, and together they satisfy the equation v plus negative v equals 0. Properties involving scalar multiplication. Distributive property. The distributive property in the context of scalar multiplication are combined with factors addition asserts that for any scalar and two factors, the scalar multiplication can be distributed across the factor addition. In other words, multiplying a scalar by the sum of two factors is the same as multiplying the scalar by each factor separately and then adding the result. Scalar multiplication with additive inverse. When you multiply a scalar by the additive inverse of a factor, you get the additive inverse of the product of the scalar and the factor. This means that the scalar times the negative of a factor gives you the negative result of the scalar times the factor. Multiplying by 0. When any factor is multiplied by the scalar 0, the result is a 0 factor. This 0 factor is characterized by having all of its components begin 0. Understanding and applying these properties are essential in fields that involve factor manipulation, including physics, engineering, and computer graphics, where factor operations are commonplace. And that's it.